Thanks to Bosch for the opportunity to be here today, and to all of you for wanting to learn a little bit about how to make this all work, how to put these unnatural alliances together. And this whole, what I'm going to talk about today couldn't have been teed up better by the conversation that the leadership from GE and Bosch had yesterday about the idea of making friends, that to realize the opportunity of the industrial internet, we've got to be able to work with sometimes unlikely friends, sometimes someone who might be thought of as a competitor. And so today, I hope I can leave you with a few thoughts on, well, how do you actually put this into action? How might you actually think about creating these unnatural alliances? So first, let me just bring you to more of an everyday experience. So just a show of hands, how many of you took an Uber or Lyft here today? Okay, fair amount. That means you had a stranger pick you up and drop you off here, kind of an unnatural alliance. Over the weekend, I was having a dinner party on Saturday night. My husband and I were running late. I pulled out my phone, pulled up my Instacart app, quickly ordered some groceries and some wine. I had one shopper, Sherry, go over to Whole Foods, pick up our dinner. Sam went over to Binny's, picked up some wine. Both got it to my house. I got dinner on the table on time. And I was able to take advantage of the fact that there were these available resources that strangers were going to offer me to help me solve a problem. Unnatural alliances. These things are happening all the time in the consumer space, and as we heard from Richard's introduction, the opportunity in the industrial space, it's such an incredible contrast to the consumer space. We have so much more opportunity to leverage, and we're just beginning to scratch the surface. So when we think about industrial, and I spend a lot of my time thinking about manufacturing, so I'm going to focus a little bit on the manufacturing side. You almost think about, we've been creating this idea of a share economy for as long as the industrial supply chain was around. The idea of taking resources from across the supply chain, being able to take those who were able to contribute a discrete part of that product and contribute it to the overall good to ultimately get the customer the product that they were looking for. Well, today, we've got this supply chain that has another element added to it. Trillions of ones and zeros. All across the supply chain, we now have an opportunity to start thinking about connections, not just about design and make connections or sales and service connections, but how do you start creating all sorts of feedback loops so that it's every part of the supply chain is now being connected and being able to take all that data that's coming out and being able to turn that data into information, and that information allows you to make decisions that ultimately are going to deliver value to your company. In fact, in manufacturing, we've got a huge amount of resources. Manufacturing creates more data than any other sector. And this really isn't very surprising, right? I mean, you think about a manufacturing floor and the amount of things that are connected, and this is just getting bigger. So we're connecting machines to each other, we're connecting workers to machines. We saw earlier about the worker who's going to walk past a machine or walk off the stage, and all of a sudden they can't use that machine. So you're connecting workers to machines, machines to machines, factories to factories, and ultimately supply chains to supply chains. So you've got this exponential growth in data that we're going to see over the next several years within manufacturing. Today, less than probably about 1% of that data is actually being used. And when you're talking about a sector of the economy that's $2 trillion, 12% of our GDP, equivalent to the 9th largest economy or country in the world in terms of economy, we've got a lot of opportunity we've got to do something about. We've got to figure out how we work together. So today I want to talk a little bit about what are some practical things that you can do within your company. And I want to share with you some of the stories about some of the things that our partners at UI Labs are doing to be able to leverage unnatural alliances. So UI Labs, as you heard Richard say, we are a collaboration platform. We're designed to bring universities and industries and startups and government and nonprofits and all sorts of players together to be able to solve problems that are too big for any of them to solve on their own. Manufacturing is a good example of one of those problems. How do you think about digitizing the supply chain, the global supply chain? You need to bring together lots of different players to be able to make those collaborations happen. So about 5 years ago, the president of the US recognized that if we want to transform manufacturing, That's a huge industry. We've got to do something about it. This is an unprecedented opportunity, an unprecedented challenge. Created something called Manufacturing USA, which is a home of manufacturing innovation institutes across the US. There's 9 of them. And by next year, there's thought to be about 15 of those, so we're growing pretty quickly. UI Labs houses one of those national centers here in Chicago. It's called the Digital Manufacturing and Design Innovation Institute, or DMDII. I'm not stuttering, there's actually 2 I's. The government gave us that long name. But DMDII is made up of these partners that you see up here on the screen. And what they're trying to do is figure out, how do we make innovations go faster to market? And how do we work together to be able to allow that to happen? So we all know that digital innovation is going to be key to the future success of our companies. In fact, 97% of CEOs recognize that. They also recognize that there's real power in collaboration, real power in working together. And those that have done it actually have the financial results to be able to show that that's true. So why are less than a quarter of our top companies in the world working with startups? And the answer is, it's really hard to do. And I pick out startups because startups are a great source of innovation. They've got a burning platform. Their survival depends on getting their product into the marketplace. The same thing could be said, though, for a university. Less than 6% of industry R&D is actually directed to universities. American research universities are the stalwart of American innovation. That's the reason America is thought of as the innovation capital. And yet, companies aren't seamlessly able to work with startups, with universities. And so how can we change that paradigm? Because if we want to make everything go faster, we want to accelerate the innovation process, we've got to bring these groups together. And for those of you who are working in large companies know, the reason this collaboration isn't happening more is it's really hard to do. Some of you are probably saying, it's really hard for me to work with the factory on the other side of the US or that factory in China, and we're part of the same company. So when you think about working with another company to be able to work on and do something in their factory, this is really hard to do. So there's a few things. I'm going to go through 5 steps today. And they're going to seem all common sense at the end of this. And I hope that it does actually seem like common sense and that it gives you some impetus to get in the game. I want you to, number 1, get in the game. Stop talking about collaboration. You've got to think about just going ahead and doing collaboration. It actually, Greg didn't know this, but he set up an example that I wanted to give. And about 15 years ago, there was a technology coming out of Argonne National Lab, which is not too far from here. And this was a technology that was looking at how do you process large amounts of data and how might you use that data to make decisions. Sound familiar, right? 15 years ago, 20 years ago, this was really novel stuff. Ended up forming a company called Smart Signal. And Smart Signal was looking at how do you take data analytics, how do you look at machine performance to better predict how and when a part might fail. It was applied to jet engines and to wind turbines. And this was some of the earliest days of what I think of now as digital manufacturing or smart manufacturing. Problem is, this company, this small company, just outside of Chicago, based on a technology invented by some researchers at Argonne, had a really hard time figuring out how to find a customer so I can test this out. Which one of you has a company that 15 years ago, or even today, you would have given your data over to a startup or to a research professor and said, okay, you tell me when my jet engine's going to fail, when my airplane's going to fall out of the sky? And this is what this company was trying to do. The thing is, fast forward 15 years, this is still really hard for startups to be able to do, to take these novel technologies and apply them to real decisions. By the way, Smart Signal turned out really well, and GE bought them a couple years ago, so a bit of a success story. But there's tons of companies today. There were handfuls 10 years ago, but there are hundreds today that are looking for that same opportunity of being able to work with companies like many of you in the room here today to be able to figure out how can we work together to bring these new IoT technologies into the marketplace. So number 1, get in the game. This can be really simple, by the way. It doesn't have to be just all of a sudden I'm going to go work with that startup, or all of a sudden I'm going to go start a corporate venture capital group, or I'm going to open my Silicon Valley office. This can simply start with just talking. And at UI Labs, actually, one of the most simple things we do is bring our partners together. Really simple. We have informal gatherings. We have formal gatherings multiple times a year. We try to do this in person, but we also have virtual communities as well. And it's about getting our partners talking about what are their problems and how can they work together to solve these problems in ways that they couldn't do on their own. And so within DMDII, our Digital Manufacturing Institute, we try to figure out what are those problems, and then we actually develop projects. So we've got about 50 projects up and running that are testing out different challenges within digital manufacturing. Just to give you a flavor of what some of those challenges are, and all of these projects began just by talking. We're trying to look at how do you use data analytics to move manufacturing left, to be able to bring the speed of design to the speed of the market. How do we connect IT systems and OT systems to be able to create the factory of the future? How can we think about using intelligent models to be able to share information more seamlessly throughout the supply chain, create a more agile, resilient supply chain? And of course, if I'm going to connect all my machines and my factories to the cloud, and I'm going to have all this data, how do I secure it? Let me tell you, talking to a bunch of small manufacturers who really make up our industrial supply chain, the idea of connecting their factories, connecting their machines to the cloud is a really scary proposition. How do we make it easier to be able to capture that data and actually be able to do something with it? So get in the game, just start talking. But then I'm going to tell you, get out of the building. And I'm sorry, the font, something happened with the font, so it's not showing up exactly here, but it says get off campus. That's what it should have said. So get off campus. If all you do is talk to the people in your building who probably work for your same company, you're probably not going to have a chance to really stretch your thinking and to really get new ideas, really be able to innovate. So maybe this means get off campus by going to your local university and sitting in on the business plan competitions for the MBA students. Or maybe it means going downtown and over to the Innovation Center here in Chicago. I mean, going over to 1871 or Catapult or M-Hub and just hanging out with some startups and see what they're talking about. There's lots of sources of innovation just by the fact that you're coming here and to this conference. Don't let today be the last time you talk to that person next to you. Think about what you might do together. Think about how you might spend some time together. Get off campus. In manufacturing, sometimes you actually need to get off campus to be able to try things out. If you take a sensor and want to put it on a machine at the risk of shutting down an entire production line, that's not going to work out so well. You're going to have some explaining to do to the plant manager. So you need to use these test beds. So again, the conversation that just happened in the previous panel is a perfect tee up to this about how do we find test beds? How do we create real life operating environments to be able to test out these new solutions and do it in a safe way? So at UI Labs, we have about a mile from here, we've got a 100,000 square foot facility. And about a third of that is a working manufacturing floor. And on the floor, what we're doing is trying to showcase how might you use different technologies within the manufacturing environment. Today, it isn't a full production line, but this time next year it will be. We're looking at how do we actually create a simulated digital thread right there. One of the things that one of our partners, Siemens, is doing is looking at how might you take digital twin technology and be able to showcase it on the floor, but then how can you integrate other emerging technologies as well? So you've got this company, Blue Vision, which is making Bluetooth-enabled devices to be able to look at things like tracking assets or looking at machine health, vibration, and temperature. And they're showing on our shop floor, how might we be able to gather that data and use it in different ways? We're bringing in startups all the time to be able to bring their technologies to life by working with some of the software and the hardware and the large equipment that our other manufacturers are bringing to the table. So get in the game, get off campus, and then do something together. So I think of this as plan safe experiments. What you're seeing up on this chart is actually what's referred to as the lean startup method, this constant iteration of trying to figure out what's the minimum viable product, what's the MVP, what does it look like to just be able to test a particular part. Maybe we're just testing, does the technology work? Maybe all we're doing is testing, can I actually collect the data that I want to collect? I don't have to go so far as to saying what I'm going to use that data for or how I'm going to analyze it. Can I simply collect it? Think about what that minimal experiment is and get started, and then be able to continually iterate. One of the parts of the MVP process, the lean startup process, is the idea of working with users and getting user feedback at the earliest stages of the process. And so again, something that by creating these alliances you're doing is you're talking to users, you're bringing users to the forefront. So I'll give you an example that some of our partners are working on in augmented reality. We already saw some really cool stuff earlier today. In fact, I think the quote from earlier today, the folks from PTC were saying, it's 8 million times faster to process information in an augmented reality situation than in reading. And you think about applying that to training environments. You look at the idea of someone standing in front of a turbine and having to make some decisions, inspect it or repair it in some way. How might you be able to transfer work instructions to that worker in a way that's as efficient as possible? Today, that's done with written manuals. And we, again, heard earlier, you can process, I think it was 3 words per second. Workers are constantly overloaded with information. Augmented reality is a tool that we can use to be able to allow that information processing to go faster. So how do you do this in a safe environment? Well, one example, we have one of our partners is Iowa State University. There's a rock star professor there that's looking at some really cool computer vision algorithms and advanced data analytics to be able to make it easier to develop work instructions in an augmented reality environment. One of the biggest barriers today to using augmented reality in the ways we talked about earlier today is that creating those work instructions takes a lot of time and a lot of very specialized labor. And if we can reduce that time, make it easier to create these work instructions in a real world application, then we can accelerate the use of augmented reality in these environments. So this professor from Iowa State needed some real world applications. He needed to talk to some users. So he paired up with some folks at Boeing and at John Deere and are now working on a project to say, how can I take an expert from your factory who's trying to demonstrate a new solution and be able to create an augmented reality video, be able to put it on a wearable device and be able to then use that expert demo to be able to train a new worker. And the professor at Iowa State wouldn't have been able to do that without having his colleagues at Boeing and Deere to be able to inform him on that process. That's just one of actually several examples of AR-type projects that our partners are working on. Again, bringing these applications in real-world environments and allowing the innovators to be able to tinker in a way that's really applicable to the user. So number 4, take risks. And this is kind of counterintuitive. I just told you to plan safe experiments, and now I'm telling you to go take risks. But the reality is that by collaborating, you're actually de-risking an environment. You're spreading that risk around. Sure, you can just not do the experiment, but that wouldn't actually lead to anything. So if you're going to do the experiment, take that risk to do the experiment, and you do it in a collaborative environment and spread that risk out. Now, within a corporate environment, you're often expected to know where the road's going to lead before you actually start down it. In fact, often you're penalized for going down and failing and not knowing where that road actually doesn't lead anywhere at all. That's the nature of experimentation at times. You've got to take the risks. You've got to be able to try something new, but you can do it in a calculated way. Give you another example of a project we're working on. One of our largest projects to date, actually, is a collaboration with GE. In 2012, DARPA, which is the Department of Defense's advanced research arm, funded GE and MIT to work on a crowdsourcing platform to be able to accelerate the design and production of advanced vehicles. We're talking about aviation systems and military vehicles. And they created the crowdsourcing platform, actually won several awards because of it. But GE believed, and GE Research believed, that there was an opportunity that was greater if they could turn this into an open source environment. So last year, we announced a collaboration between GE Global Research and DMDII, our Digital Manufacturing Institute, to be able to take that early crowdsourcing platform and turn it into what we're calling the DMC, the Digital Manufacturing Commons. And what we're trying to do is create an environment, a virtual community of OEMs and suppliers and software developers and entrepreneurs, technology vendors, anyone. We want you to come to the table and figure out how can you work together in this virtual environment to safely exchange data, to aggregate it, to analyze it, and do it in a way that allows you to be able to take risks and do something that you normally maybe wouldn't want to do in a real environment and do it virtually. We're launching early next year. I hope you'll come take a look at what we're doing. But in the meantime, we've started a series of hackathons. We had our first one earlier this summer. We'll have another one at the start of the year. And just by the nature of participating in those hackathons, we've seen companies get off campus and take risks and plan safe experiments. So you can kill 3 birds with 1 stone by coming out and checking out what we're doing with the DMC. Moving on to step 5, and perhaps the hardest one here, is that to be able to do all the things we're talking about today, it means about changing direction. It means about not following what the status quo is doing, but trying something new. And changing culture, changing organizational dynamics is something that's really hard to do. And so I definitely don't underestimate the challenge of step 5, which is to think differently. How do you even begin to think differently? And so what we've tried to do is bring our partners together to try things that they know they really feel that it really is going to work if we could just have that safe environment to work on it. So I think right after I speak, we're going to have some folks talk about model-based engineering. And for those of you who know about MBE, you know that there's a lot of great results from companies that show 30 to 50% reduction in time and labor costs when you use model-based engineering, model-based design. The challenge is the technological part isn't necessarily the hardest part of it. It is the cultural change that's necessary to be able to have your entire supply chain use this type of engineering to be able to exchange information with one another. So one of our partners, Rolls-Royce, has partnered with a very large team, includes Lockheed Martin and Microsoft and Purdue University and a bunch of small technology companies and suppliers to say, we know MBE works, so that's not what we're testing. But instead, we're going to create a methodology. We're going to document a methodology that can be shared with not just those of us in the project, but all of those who are part of this collaboration to be able to actually train suppliers on how to use MBE techniques, how to be able to exchange intelligent models throughout the supply chain to more efficiently, more effectively exchange data, again, reduce time, reduce costs. This is just a flavor of some of the work that we're doing at UI Labs to really push our partners to think about how to create these unnatural alliances. So I hope today that what you come away with is that there are some practical things that you can do, and some of them are a little bit easier than others, of course, but there are places. The Industrial Internet Consortium is a great example of the type of ecosystem building. There's probably many of you in the room are involved in different collaborative efforts and continue to leverage those to think about how can you get in the game, get off campus, plan safe experiments while taking risks, and think differently. And remember, the experience itself, regardless of what the outcome is going to lead to some contagiousness. You're going to become a contagious innovator who wants to go back to your company and think about new ideas with more gusto about what you're going to do next. So thanks so much for your time today.